In this video, I'm going to work on the example of normal probability distribution. This is the example that I will be working on, and there are 4 parts to it. Let me read the question first. The SAT math scores in a certain country are normally distributed with an average of 620 and a standard deviation of 50. Now, let me make a graph here. And we know mean is in between, so in this case, mean is 620, so 620 is here. For this problem, we are supposed to find these different probabilities. Now, let's work on this problem one at a time. First, let's look at the very first problem. So here we are supposed to find a probability that a student has a SAT math score of above 700. So let me make a diagram for this given scenario. We know our mean is 620 and which is in the middle here. And here we are supposed to find the probability that a student has a SAT math score of above 700. Let's say our 700 is right here and we are supposed to find this area. What that means is we are supposed to find this probability here. To find this probability here, you can use calculator, you can use Excel, and you can also use table. So first, let me show you how to find this probability here using calculator. For that, let me pull up a calculator here. Then go to second distribution. We'll be using normal CDF function. Then hit enter. So for this, we will need lower value, our upper value, mean, and standard deviation. Let me clear what I have on here. So looking at this diagram here, we know our lower value is 700. So let's put that there. For upper value, we'll need really large positive numbers. So let me put 10,000 there. And our mean is 620. And our standard deviation is 50. So let's put that here. 50. And now hit enter and enter. So we got this to be 0.0548. This area here is 0. Let me just write that down. Here is 0.0548. Now let me show you how to find the area using table. So for that we can use this formula where z equals to x minus mu over standard deviation. Our x in this case is 700, our mean is 620, and our standard deviation is 50. So that comes out to be 1.6. Now we need to look this z-score in table to find this area here. Now let me pull up my table. So now to find the area for 1.6 z-score, we will look at the row of 1.6 and column of 0.00. So that means the area to the left is 0.9452. This number here. Basically, the area to the left of 700, which is this area, is 0.9452. If you look at this diagram here, we are interested in the area to the right. And we know the whole area here is 1. So all we need to do is subtract this number from 1. On doing that, we get 1 minus 0.9452 0.552 equals to 0.0548. And this is the probability that a student has a SAT math score of above 700. Now let me show you how to get that in Excel. For that, type in equals, then type in norm.dist, then put your parentheses. Our x here is 700, and mean here is 620, and standard deviation is 50. Here we are looking at the cumulative probability up to 700, so we will just type 1, or you can also type true, TRUE. Then close parenthesis, then hit enter. This number here is the area to the left, but we need area to the right. So all we need to do is subtract this number from 1. So let's do that. For that, type in equals, then type 1 minus this number here, then hit enter. And this is exactly what we got using calculator and also table. Now let's look at the second problem here. Here we are supposed to find the probability that a student has a SAT math score between 550 and 700. So let's draw a diagram for the given scenario. We know mean is in between, which is 620. So let's say our 550 is here and our 700 is here. So we are interested in this area in between 550 and 700. This area in between. So let me show you how to find this area using calculator. Let me pull up my calculator on the screen. Go to second, go to distribution, go to normal CDF, then hit enter. Let me clear what I have here. So our lower value, looking at this diagram, our lower value is 550. Let's enter that. Our upper value is 700. Let's enter that. Our mean is 620. Let's enter that. And our standard deviation is 50. Then hit enter. Then hit enter. So we got this number here, and this is the area in between. And that's what we need. Basically, so let me write that down here. So this area in between is 0.864. So this is the probability that a student has a SAT math score between 550 and 700. Now let me show you how to find this using table. So to find the area in the table, first we need to convert this into, first we need to find z-score for 550 and 700. Let's find z-score for 550 first. Z equals to 550 minus 620 over 50, which is equals to negative 1.4. Now, let me pull up the table first so that we can look up for the area. To look for the area, we need to look at our z-score is negative 1.4, so we will look at the row of negative 1.4, which is this row, and column of 0.00, which is this column. So therefore, the area is 0.0808. Basically, the area to the left of 550, this area is 0.0808. Now, let's find the z-score for 700. So that is z equals to 700 minus 620 over 50, which is equal to 1.6. Now let's find the area for this z-score from the table. So let me pull up my table here. So the area for z-score of 1.6 is, for that you'll be looking at the row of 1.6 and column of 0.00, which is 0.945 to this. So let me put that down here. Basically, the area to the left of 700 is 0.9452. We are interested in the area in between. So for us to find this area in between, we need to subtract this number, this value from this number here. So let's do that. On subtracting this number from this number, we get 0.864. And this is the same exact number that we got from calculator also. Now, let me show you how to do this in Excel. Let me pull up my Excel up here on the screen. First, let's find the area to the left of 550. For that, we need to type in equals, then type in norm.dist, then put your parentheses. Our x here is 550. Our mean is 620. And standard deviation is 50. Then type in comma. Since we are looking at the cumulative probability up to 550, we will type true. Then close your parentheses, then hit enter. So this is the area to the left of 550. Now we need area to the left of 700. So for that, type in equals, then type in norm.dist, then put parentheses. Our x here is 700. Mean is 620 and standard deviation is 50. And again, here also, we will type true because we are looking at the cumulative probability up to 700. So let me type true, then close our parentheses, then hit enter. So this is the area to the left of 700. So this one, we are interested in area in between. So we need to subtract this number from this number. So let's do that. Equals that minus that. Then hit enter. This is what we have here. And this is exactly what we got using calculator and also using table. Now let's look at another problem. Here we are supposed to find percentage of students that have SAT math score of below 580. Let's draw a diagram for the given scenario. And our mean is here in between, which is 620. And let's say our 580 is here. And we are interested in this area below 580, which is this. Let me show you how to find this area in a calculator. For that, go to second distribution, then we'll be using normal CDF function, then hit enter. Let me clear what I have on the screen. For your lower value, let's look at the diagram here. For your lower value, it will be large negative numbers. So for this one, I will be using negative 10,000. And for your upper value, from the diagram, we know it is 580. So let me put that here. And our mean is 620. And our standard deviation is 50. Then hit enter and enter. We got this number, and this is the area over here, which is 0.2118. Here, we are supposed to find the percentage of students that have SAT math score of below 580, which is 21.18%. So let me put that down here. That is 21.18%. Now let me show you how to find this area using table. For that, we need to first find z-score for 580. Let's do that. For that, we can use formula for z, which is z equals to x minus mean over standard deviation. Our x here is 580, our mean is 620, and our standard deviation is 50, which equals to negative 0.8. Now, we will need to look up in our z table and find that area. For that, we'll be looking at row of negative 0.8 and column of 0.00. So that means this is the area, 0.2119. That means this area here is, area to the left of 580 is 0.2119. And for us to convert that into percent, all you need to do is multiply that by 100 and you'll come up with this percent here. Now let me show you how to find this area using Excel. For that, type in equals norm.dist, then put your parentheses. Our x here is 580. Our mean is 620. And our standard deviation is 50. Here we will be typing true because we are looking at the cumulative probability up to 580. Then close your parentheses, then hit enter. So this is the area to the left of 580, and this is exactly what we got using table and calculator also. Now let's look at the very last problem here. This one. So here we are supposed to find percentage of students that have SAT math score between 650 and 750. Let's make a diagram for the given scenario. So our 620 is mean, which is right here. That means our 650 is here, and our 750 is here. And we are interested in this area in between 650 and 750. So to find this area in calculator, all you need to do is, let me pull up my calculator first. So go to second, distribution, then we'll be using normal CDF function. Then for your lower value, looking at this diagram, we know lower value is 650 and our upper value is 750 and our mean is 620. Our standard deviation is 50. Then hit enter and enter. Okay. We have this number here for the area between 650 and 750. So here the question is asking us to find percentage of students that have SAT math score between 650 and 750. For that, all we need to do is multiply this number by 100 times 100. We get 26.96%. Okay. So that's the percent of, let me put that down here. So that's the percentage of students that have SAT math score between 650 and 750. 26.96%. Now, let me show you how to get this area using table. So for that, we need to find z-score for 650 and z-score for 750. Let's try to do one at a time. Let's do for 650 first. We know formula for z is x minus mu over standard deviation. So when we are trying to find z for 650, our x is 650, and our mean is 620, and our standard deviation is 50. So this comes out to be 0.6. Now let me pull up my table here to find the area to the left of 650. For that, we'll be looking at the row of 0.6 and column of 0.00. So here, that area is 0.7257. So let me put that in a diagram here. So area to the left of 650, basically from here to 650 is 0.7257. Now let's find the z-score for 750. So for that, all we need to do is plug in the values in this formula here. We get z equals to x, in this case is 750, and mean and standard deviation are same, which is 620 over 50. So this comes out to be 2.6. Now, we need to find the area for 2.6 in this table here. So let me pull up the table first. So we'll be looking at the row of 2.6 and the column of 0.00, which is right here, which is this one, 0.9953. So this is the area to the left of 750. So basically this area here. So that is 0.9953. Since we are interested in the area in between, so all we need to do now is we need to subtract 0.7257, this number, from that number here. On subtracting that, we get 0.2696, and since the question is asking us to find the percent, all you need to do is multiply that number, which is 0.2696 by 100, you will get 26.96%. And this is exactly what we got from calculator also. Now, let me show you how to get this area in Excel. For that, let me pull up my Excel here. So let's try to find the area to the left of 650. For that, you will be typing in equals, then type in norm, norm dot dist, then put your parentheses. Your x here is 650. Your mean is 620. Your standard deviation is 15, and then you can type either 1 or true, because here we are looking at the cumulative probability up to 650. So I'll just type 1 here. Then close your parentheses, then hit enter. So this is the area to the left of 650. Now we need an area to the left of 750. So let's find that. Type in equals, then type in norm dot dist, then close your parentheses. Your x here is 750 and mean is 620. Then your standard deviation is 50, and again in this case, since we are looking at the cumulative probability up to 750, we can just use 1, or you can just type true. Then close your parentheses, then hit enter. Now, to find the area in between 650 and 750, we need to subtract this number from this number. Okay, so let's do that. For that, type in equals, then select that, minus, go select that, then hit enter. So this is the area between 650 and 750, and the question is asking us to find percentage. Now, all you need to do is multiply this number by 100. Let's do that. Type in equals, then select that, then times 100, then hit enter. So we got this when we multiply 0.269592 by 100. And this is exactly what we got using table and also calculator, which is right here, 26.96%. And finally, we are done. And here I have listed all these answers, probabilities, and percentages at one place. Thank you for watching. We hope this video was helpful. Please like and subscribe our channel. We will be bringing more and more videos on variety of topics.